Let us define what conic section is. A conic section is the intersection of a plane and a cone. By changing the angle and location of intersection, we can produce a circle, ellipse, parabola, or hyperbola. So what are the parts of conic section? Let us first define circle. It is the set of all points on a plane that are a fixed distance from a center. Next is ellipse. An ellipse is the set of all points on a plane whose distance from two fixed points, f1 and f2, add up to a constant. Next is parabola. A parabola is a curve where any point is at an equal distance from a fixed point, the focus, and a fixed straight line, the directrix. Lastly, the hyperbola. A hyperbola is a curve where the distances of any point from a fixed point and a fixed straight line are always in the same ratio. It is actually two separate curves in mirror image or symmetrical of each other. Now we know the different parts of a conic section. Let us focus on its two parts, the parabola and the ellipse. Let us start with the parabola. We can find parabolas in bridges, domes, theaters, rainbows, and even when eating a cookie. A parabola is a curve where any point at an equal distance from a fixed point. A parabola can open upward, downward, leftward, or rightward, depending on its equation. The equation of a parabola opening to the left or right is given by y quantity squared is equals to 4px. The equation of a parabola opening upward or downward is given by x quantity squared is equals to 4py. The vertex is given by h and k. Now that we have defined parabola, let us do some exercise. Given the equation x minus 1 squared is equal to y plus 4, graph the parabola. The vertex h and k is given by negative 1 and 4 in the equation. But before getting the coordinates, you should first invert the signs of h and k, and after that, we achieve the coordinates of the vertex 1 and negative 4. From the equation, we see that p is equals to positive 1 over 4. Since the quantity of x is squared from the equation, we know that this is a parabola opening upward. To know the length of the latus rectum, we multiply p by 4 and we achieve 1. The latus rectum will show us how big the opening is by adding its half to the focus. We now have a center, vertex, a focus, and the latus rectum. It is time to graph. Now let us have some word problems. A dome-shaped planetarium is being made in Manila. The distance of the vertex from the ground is 90 feet. The vertex of the planetarium is attached to a cable from the ceiling to prevent the planetarium from collapsing, and the distance of the ceiling from the ground is 120 feet. The engineers needed to find the right distance from the vertex to hang the laser star projector where it could shine throughout the dome equally. Find the right distance of the laser star from the ground. Now the ellipse is a simpler conic section. We can find ellipses in cells, track and fields, and even the very orbit of our solar system. An ellipse is the set of all points on a plane whose distance from two fixed points, f1 and f2, add up to a constant. The two fixed points are referred to as the foci. The standard formula of an ellipse is given by x quantity squared over a quantity squared plus y quantity squared over b quantity squared is equals to 1, where a is the major axis and b is the minor axis. And remember that the major axis of the ellipse is always longer than its minor axis. The previous formula shows a horizontal ellipse, and the following shows a vertical ellipse, where y quantity squared over a quantity squared plus x quantity squared over b quantity squared is equal to 1. Now let us have some word problem for ellipse. Lithotripsy is a treatment process of using shock waves from electrohydraulic or electromagnetic energy systems, mostly to shatter kidney stones into smaller particles that can be passed out by the body. This can be done by using lithotripter. To apply it in lithotripters, the shockwave generator or electrode serves as F1, while the point where the shock waves are concentrated and at the same time the location of the kidney stone serves as F2. The brass reflector, which has an elliptic shape in its opening, represents the ellipsoid with the lithotripters, making sure that the reflected ray is always reflected to the kidney stone. So this is the problem. The lithotripter's ellipse has a major axis of 12 feet and a minor axis of 5 feet. Assume that the center is located at the origin. How far from the center are the foci? How far from the lithotripter's shockwave generator is the patient's kidney? Write an equation for the ellipse used. Given the values of A and B, the equation of the lithotripter's ellipse is y squared over 144 plus x squared over 25 is equals to 1. As we look around us, we realize that the world is aided by several applications of conic sections, especially parabolas and ellipses. We all know that the parabola is the curve formed from all the points, x and y, that are equidistant from the directrix and the focus. If you still couldn't imagine what a parabola looks like, McDonald's arcs are parabolas. In real life, parabolas can reflect any light or sound ray entering the parabola parallel to the axis of symmetry and hitting the inner surface of the parabolic bowl. Satellite dishes are a good example of this property of the parabola. It concentrates a signal onto a receiver, whereas an ellipse is a curve on a plane surrounding two focal points such that the sum of the distances of the two focal points is constant for every point on the curve. Satellite and planet orbits are considered ellipses. Studying parabolas and ellipse may cause the students such pain, headache, or even traumatic experiences, but we must learn how to appreciate such art. Although we might not notice it, but conic sections greatly affect our daily lives.